Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the limiting behavior of p hat. What happens to the distribution of our sample proportion as n, the number of people I ask or the number of trials, gets larger and larger. So let's use as an example me wanting to find the proportion of people who have blue eyes. Well, of course, I can't ask everyone. That would take forever. So I would just ask a sample of people. P hat is the proportion of people in my sample who have blue eyes. Now, P hat is basically just a mean. When I'm asking people whether or not they have blue eyes, I'm basically giving them a score of 1 if they have blue eyes, 0 if they have eyes of another color. So calculating p hat is like calculating the mean of all these scores of 0 and 1. 0 for everyone who doesn't have blue eyes, 1 for everyone who does have blue eyes. So the central limit theorem, we're not going to go through that too much. It's a very important theorem, but it relates to means. It basically says that as n, in this case the number of people I ask, gets larger and larger, the distribution of sample means is better approximated by a normal distribution. So what that means is, because p hat is basically like a mean, if I ask more and more people, if n gets larger and larger, the distribution of p hat becomes more and more like a normal distribution. In fact, the approximation is better the closer p is to 0.5. So in this rule here, I said p is close to 0.5 and n is as large as possible. They're not really concrete rules. So the rule we're going to use is that the normal distribution is a good approximation of the distribution of p hat, the sample proportion, if both of these are true. If n times p is greater than 5 and n times 1 minus p is greater than 5. This is just basically how we're going to test if these things are true. If p is close enough to 0.5 and n is large enough. So p hat will follow a normal distribution. Its mean will be p, the true population, and its variance is what we calculated as the variance last time. But remember, if you have a random variable that follows a normal distribution, you can easily convert it to a standard normal or z distribution by using. So as n gets larger and larger, this formula here is just the z-score. It's our score, our proportion, minus the true mean, the true proportion, divided by the standard deviation. Z-scores follow a normal distribution with mean 0, standard deviation 1, if the original scores were from a normal distribution. So how is this useful to us? Well, this will be useful in cases where we know p. We know the true proportion of people that have a characteristic like blue eyes. This will allow us to calculate the probability that our sample proportion is within a certain range. If I know the true proportion of people who have blue eyes is, say, 30%, for example, I can figure out, for example, the probability that in a sample, between 25 and 35% of people have blue eyes. So let's look at an example of this. So let's say we know that 15% of students at Marist have some Italian heritage. We're going to take a random sample of 150 students and find the probability that between 20 and 30 students in that sample have some Italian heritage. All we're really doing here is using z-scores to find the probability of getting a certain proportion of people in our sample. So here we know the true population proportion is 0.15 or 15%. We're calculating probabilities involving p hat. So all we're going to do is convert these to z-scores, and then we're going to find the probability of being within that range. So if 20 people out of 150 people have Italian heritage, then p hat would be 2 over 15. So if p hat was 2 over 15, that would be a z-score, so z-score minus true mean over the standard deviation. So remember the formula for the standard deviation involving the proportions, it's p times 1 minus p, all divided by n. So n is the number in the sample, in this case 150. So putting that in our calculator, we get about minus 0.5717. So that means that if I got 20 people in the sample that had Italian heritage, this would correspond to a z-score of 0.57 standard deviations below the mean. Similarly, if 30 students had Italian heritage, in that case, p' would be 30 over 150, which is 0.2. So, converting this to a z-score, we have score minus mean, or score minus original value for p, over standard deviation, which is the square root of p times 1 minus p over n. So putting that in our calculator, we get about 1.715. So really what we're asking here is that in a standard normal distribution or a z distribution, what is the probability of getting a z-score between minus 0.57 and 1.715? So remember, for a normal distribution, if you want to find the probability of being between two values, use normal CDF, and because we're using the standard normal distribution, mean 0, standard deviation 1. So if we put that on our calculator, we get about 0.67. So there's about a 67% chance that in your sample of 150 random students, you would have between 20 and 30 students having some Italian heritage. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.